Okay, today's lesson is about the interior angles of triangles. In the previous lesson, we looked at the different types of triangles, and they were determined by two things: their types of angles and also the symmetry. So equilateral triangles have three equal sides as well as three equal angles, which happen to be 60 degrees. Notice how the notation here means that all three sides are the same length, and also that equilateral triangles have three lines of symmetry. Isosceles triangles have two equal sides, two equal angles at the base, and it has one line of symmetry through the middle. Scalene triangles have no sides of equal length, no equal angles, and no lines of symmetry. The other triangle is a right-angled triangle that contains a right angle. We can also describe each triangle by the type of angles it has on the inside, whether it's acute, obtuse, or whatever. So that sums up what we did last lesson. Today I'm going to start looking at angle rules to do with triangles. And the first thing is the internal angles of a triangle. So the internal angles of a triangle add up to 180. And this can be really useful at working out questions like we've got on our screen here. So we can write out that all three angles, x plus 125 plus 45 equals 180. Through this rule. So then, because the only unknown is the angle x, we can use that then to work out the size of x. So 180 away 125 plus 45, which gives us 180 take away 170, meaning that x must be equal to 10 degrees. So this angle here must be 10 degrees. But the bigger question is, how do we know that all the angles in a triangle add up to 180? So how can we prove it? And there's a number of ways we can do it. The first one I want you to do is have a go at the following exercise. So you will need a scrap piece of paper, and then on that scrap piece of paper you get a ruler, and then just choose a triangle of any angle, any size, as long as all the points meet. And then what you're going to do is, on your paper, once you've drawn your triangle, label it A, B, and C. Then you have to cut out the triangle, and then I want you to tear off the corners. Tear them off so that they're big enough that you can still handle them. And then what you should be able to do is that we should be able to put them together, because if these angles add up to 180, what's the other thing that we know adds up to 180? A straight line. They should make a straight line or 180 degree angles there. Then there's a 6 where you can fill in those gaps. So what I want you to do is pause the video, do that exercise, glue those corners into your book, and eventually you can take a photo of them and upload them to OneNote. So pause the video now and complete that, please. Okay, so you should have had a go at putting that together. So let's take a look at part 6. After you've glued those three pieces together, copy the sentences. So A, B, and C are three angles of the triangle. When placed together, they form a straight angle. A straight angle measures 180 degrees. So the three angles of the triangle together add up to 180 degrees. the sum of all angles in a triangle A plus B plus C must equal 180 degrees. And this will be the case for any triangle that you have. So here I've got a quick video of what we should have completed, or you should have completed, just illustrating the point. Okay, so there you can see that the three angles we have here have created a straight line on this side, so A, B and C must add up to 180 degrees. Okay, this little diagram also explains a little bit of how the angles of a triangle add up to 180. So we've got our angles there in green are equal, and that's because they're alternate. The red angle here and the red angle there are alternate. So it makes sense that because this angle here is shared by the triangle and the straight line, that if the rest of it's the same, it's going to have to be the same on both, which means that both of it must equal 180. So you can see it makes a straight line there as well. So how else can we use this rule? And this comes up a lot with looking at isosceles triangles. So we've got a question here with this first triangle of unknown angle y and an unknown angle x. So the first thing that we can look at in the first question is trying to use some of the features of an isosceles triangle. We've said previously that the base angle, because there's a line of symmetry in an isosceles triangle, that 57 and x must be the same. So x must be equal to 57 degrees, and the reason for that is base. Remember, we should always try to give reasons of an iso triangle. Notice the shorthand. Rather than writing triangle, I'm drawing a triangle. Rather than writing angle, I draw an angle. So how does that help us? We end up with 57 degrees then. Then there's only one unknown angle. What we can do is use our normal calculation. So 180 equals 57 plus 57 plus y. So that means 180 take away 114 must be equal to y, which leaves us with 66. Y is equal to 66 degrees. So looking at the second triangle there, again, we're missing a little bit of information. We're going to use this line of symmetry again to say that this angle must be x as well. There's a couple of ways you can do this. If you are sure that this is a 90-degree angle here, then you could make this 15. But since we're not sure of that, I'm not going to. and I'm going to use the bigger triangle instead. And how we do that, 80, it's the angles in the triangle, and that must be 30 plus x plus x. Now, because both of those x's are the same size, it must be twice x, or 2x, and 30 is equal to 180. So it makes sense that it's 180, I'm giving myself enough space there, 180 take away 30 must be equal to 2x, or twice x, and that's 150 is equal to 2x, so 1x, or half of 2x, is 75 degrees. So it must be 75, 75 there, which makes sense because it adds up to 180. So they're the types of questions you're going to come up against. There's a worksheet or work out of your textbook you need to complete, and make sure you upload your answers onto OneNote.